Hello, everybody. Thanks for joining today. We're going to talk about our latest release. It's so-called the October release today. And I have quite an agenda to go through, so I suggest we get started. So this is what we call our October release. It has already been deployed for those customers that are using the Waylay hosted solution. So all of the features that you see here today have already been deployed. You can use them, and they are also available in the documentation. So first and foremost, you should have received an email a few weeks ago with an announcement that we just released the so-called Waylay forum. The Waylay forum is new, and it's available for those that have a Zendesk account. Zendesk is the tool that we currently use to submit tickets to Waylay. Now, the same account also allows you to get access to our public forum. So this forum is available to all of the Waylay users, also the developers. Product management is on there. And on that forum, you can request more information related to best practices. You will find information about the various features of the product and questions from other customers as well. So it's a public forum, so be careful what you post there. But in case you're looking for additional information that you cannot find, feel free to leave a message there, and we'll make sure that it gets answered. Like I said, you have to use your Zendesk account, and once you use the URL that is here, you'll end up on our forum page where you can browse around and make new posts as you see fit. The agenda for today is the following. I have like 6 items that I want to go through. First of all, we have a few new features related to data ingestion. We also have a few features that allow you to simplify your rules. I'm also going to talk about the Python SDK that we now have available, typically to be used by data scientists. We have a new component, a new module in our portfolio, which is the provisioning portal. I'll show a demo of that as well. And I'll also talk about some new features in the Waylay dashboard. And last but not least, let me give you a sneak peek to our next major release, which is targeted for Q1 next year. What comes in that release? I'll not go into detail, but highlight a few main points there. But for today, we're going to focus on this minor release here, and let's get started with the data ingestion features. Okay, so probably you know that we have this concept of channels, and channels is a way for us to integrate with existing IoT platforms like Azure IoT, AWS Cloud IoT, and MQTT, for example. And often what you see with these channels is that the data that we receive through those channels is kind of noisy, meaning that there's a lot of data in the payload of these messages, and not all of that data is useful for the rule engine. So we now have an additional means of filtering and converting that payload into something that is useful for the rule engine. And for that, we have introduced a channel payload converter that you can program via the API. Okay, so what does that mean? Well, it basically means that, for example, let's say here on the left-hand side, this is an example of a message that comes in through the Azure IoT channel, right? As you see, there's quite a bit of information related to metrics, humidity, temperature, etc., but also a lot of additional information that is not immediately useful for the rule engine. Obviously, what is definitely useful is the device ID. For example, here in this case, the G-sensor wheel loader is the device identifier that is being used in Azure IoT. And that is something you actually want to keep in sync with the resource identifier that is being used within the Waylay platform. Okay, and this is something that you can program. This mapping is something you can program via the converter. Okay, so here is, for example, a mapping file. For those that are a little bit familiar with velocity templates, that's the language that we use to make those mappings. Okay, so here, for example, you see the Waylay resource identifier is mapped to payload 0 body device ID, which is basically this part, okay, or this part. It depends on what exactly you would like to use. Okay, and then you see some of the metrics that we also extract out of the body. Okay, so when this data is actually entering within Waylay, this is effectively what you will see on your resource with this name. Okay, so these are the metrics that are then automatically parsed. Here, everything is kind of parsed as a string, but we also provide type mappings, for example, to map humidity to, for example, an actual floating value. Okay, so these capabilities are described in the documentation. So if you go to this link, here you will find how you can use the converters for different channels. MQTT is one of them, but you can use it for other channels as well. How to use the velocity templates, and some more information and various examples on how you can use that. There's also an API description available. The API description is here. It's also, you can easily find that also in the documentation. And this API documentation describes how you can program these converters. Okay, so how to use these converters? Well, for example, if you go to your Waylay environment and you have your different channels. For example, here I have an Azure channel up and running. So if I click edit here, this is where you can actually select which converter you want to use. So if you use the API to upload a converter, this is where you can actually, per channel configuration, define a particular converter that should take the payload and to convert it to something more appropriate for the Waylay rule engine. Okay, so it's pretty easy to use, but you have to be a little bit familiar with velocity templates, and we provide quite some documentation there on how to do it. All right, let's move on. We also made a few updates on the Azure channel, as we call it, to make it a bit more generic, in the sense that the Azure channel is not only limited anymore to Azure IoT Hub. We also have made it generic such that you can hook up any Azure Event Hub to that channel. Okay, what does that mean? Well, for those that are familiar with Azure IoT Hub, they actually have inbuilt endpoints that are actually an embedded event hub that you can subscribe to. But for example, if you go to Azure Digital Twin, which is yet another product of the Azure portfolio, there they use more explicitly the event hub framework to post their messages. So any Azure event hub can be configured now under the Azure channel. And like I said, it's not only limited anymore to IoT Hub, it's now more generic. Okay, we provide quite some documentation on how to do that. So you can find it here, and you just have to, as usual, go to shared access policies and kind of configure your connection string. So the principle is the same, but now it's a bit more generic to be able to connect Waylay to any Azure event hub. Okay. In terms of the other channels that we have available, no change there, except for the ability to connect a converter to it. You don't have to; it's an optional thing. But if you're not interested in all of the data that is in your message, then I would recommend to use a converter to extract the useful information there. Okay. Okay. So let's get back to our presentation here. So the next subject that I wanted to talk about is the simplification of the rules. So we provide a few new capabilities to simplify your rules. What does that mean? Well, first and foremost, we have the concept of declarative context binding. What does that mean? Well, there's actually quite a bit of documentation on this link here. So if you go to docs.waylay.io and you go to our API documentation for creating sensors and actuators, you will find a new category here called declarative binding, where you will find a lot of new information that wasn't there before on how to use it. So for those that are familiar with the Waylay platform, what you see on the left-hand side is often a recurring pattern that you use in your rules to process streaming data. So you have a streaming data sensor that that basically takes in particular data. You particularly focus on one metric, and then you shoot that to, for example, a function node that does some calculation on this metric. Metric could be, for example, temperature, or in this case of this example, it's a gyroscope X and Y value. Okay. So this pattern is something that people often reuse. Now we can actually simplify this. You don't have to use this starting node anymore. You can just simply use this function node and provide contextual binding related to the actual formula. So if you enter this information in your formula, which is basically saying that you're interested in the streaming data, but only this particular metric, the gyroscope Y value, then you actually realize exactly the same as these two nodes together. Okay, but in this case, you would only have to put one node, this function node, into your rule. Okay, and the rest is exactly the same. So in this case, you basically save on one API call here, which is the streaming data sensor. Okay. So this is something that we now have available within the product. This function node is now smart enough to know how to use the incoming data and which metric it needs to extract from that. Okay. So that's one. There are a few examples on our documentation page here. Especially around the declarative binding documentation on how to use it and how you can actually use it in a flexible way. So it's not only limited to this function node; it goes way beyond. But in the interest of time, I'm just highlighting here one typical example that you probably recognize and use today as well within your rules. So there you can simplify your rules. Okay. The second example is a little bit more elaborate and is called the query designer. Okay, so what is the query designer? Well, the query designer is accessible through a new tile that is in your environment. So if you go to the home page of your administrator console, you will find here in red a new tile that is called queries. Okay, so this tile allows you to define queries on the time series data. Okay, what does that mean? Well, it's basically you can compare it a little bit with a stored SQL query that allows you, for example, here to define a particular data query for metrics of one resource, but it could also be across multiple resources. Okay, so here, for example, I'm now in the query designer. I have basically selected here my series, and my X series is coming from bearing 2,4, which is one resource, and I'm pulling out here the horizontal vibration data. This is this data set here in blue. It corresponds to the vibration data on the x-axis, and here my y series is corresponding to the y-axis vibration for the same resource, but you can add here any resource that you want. So this allows you to actually compile quite complex queries. Okay. Now, what is the advantage? You can now actually use these stored queries in your rule designer as well. So on the left-hand side, you see a pattern that you probably recognize, where in the past you had to pull data from a particular metric for a particular metric of a particular resource with the time series data sensor, right? And you had to pull that out of the time series database one by one, and then use a script node to combine these together and then do some stuff with it. For example, send it to a bring your own ML node further. Okay. Now, all of this, all of these individual queries for individual metrics of individual resources can now be combined with the query data sensor into one node that performs all of this in one go. Okay. And of course, this query data sensor is going to use your stored query in order to do the rest of your logic. Okay. So clearly here, that simplifies quite a bit of your rule design. It simplifies it. It improves the readability, and it also saves a bit on number of API calls. So let me give you a concrete demo of this. As I've already shown you here, I'm selecting data for a particular resource called bearing 2,4, which is a bearing, for example, that is related to a machine. And this is the data set in our time series database for our horizontal and vertical vibration measurements of that bearing. So as you can see, over time, this vibration is heavily increasing. This is like, in this period, you have like the normal behaving bearing with a little bit of vibration, but here you have a lot of vibration, which might indicate that your bearing is has some wear and tear and is likely going to cause some malfunctioning on the engine. Okay, so the use case that I'm going to show in a minute is we're basically going to query this set of data on a regular basis using the query data sensor. And we're going to shoot that to a machine learning algorithm that is going to detect anomalies. And based on those anomalies, we're going to raise alarms. Okay. So how does that work? Well, here I've defined my my query, and I've saved that query as well. So if I save this button, click this save button here, I'm saving my query under the name bearing query, which I already did. And if you go to your query data tile, if I go back here, so if I click here, queries, you can in the first page see what are all the stored queries that you've saved before. And one of the ones that I just saved here is the bearing query. Okay, so let's have a look on how you can actually use bearing query now in your rule. So I have a nice example here where I have a bearing monitor use case here. This is my my template. Okay, so what I'm doing here is I'm basically going to run my query. Here you see the query name that I've configured on this query data sensor, and I also define here a window which is basically saying, hey, I'm going to look back for the last minute what data has come in. And based on that, all of that data, I'm going to send that to the next node, which is a an algorithm that is running. It's a Python algorithm that is going to detect anomalies. It's not important for now. But what comes out is a series of ones and minus ones that are indicating for each of the samples that I'm querying whether they are anomalies or not. And then I'm going to print it out here on the debug dialog whether there are any issues. Okay. So let's go to labs and shoot some data in this one. So let me make sure that I start this one. This is for later. But here, let's start and have like our comparing 2, 4. I have some pre-recorded data. That one. Store the data. I'm gonna just basically loop over it and push this data to broker repeatedly, for example, every 3 seconds. Okay. So while this data is kind of going in, so here you see the actual horizontal and vertical vibration signals coming in. I'm gonna start this rule in debug mode. Here, task type, we're gonna assign it to our resource bearing to 4. I'm gonna say it's a periodic task, and the polling frequency is like every, let's say, 4 seconds, right? So let's start this now, and let's see what's happening in the debug dialog. So every time, every 4 seconds here, this query is going to be called, and it's going to look back for 1 minute what kind of measurements have come in. All right, and then this data is sent to the YOML predict node, and it's basically going to fire whenever there's an anomaly detected, right? So in a few moments, I think the debug dialog should fire, depending on the data that we're shooting in. So with a little bit of luck, I already see -1s coming in. So so the data that we're gathering is here, and this one is coming in. So there we go. We already have an alert here. So this debug dialog is already detecting a number of outliers. So outliers basically means that the anomaly algorithm has looked at the data that the query data sensor has shoot in, and we have a lot of -1s, and which basically means that a lot of samples here, more than 20%, are actually abnormal. And this algorithm is in this way kind of detecting these anomalies. So clearly here, an action needs to be taken to prevent the machine from going down. Okay, so let me stop this here right now. So as you can see, what is the major advantage here is that with the simple one node, we're actually gathering the necessary data that is needed for this algorithm to work. And you can just use this simple node here to shoot and collect all your data for further processing within your rules. Okay, this is a major improvement over what you had to do before, which is basically define for every metric this time series sensor and collect that data and then combine it with the script node and then process it further. Okay. So this is greatly improving the readability of your logic. Okay, so feel free to use it. The designing of your queries is completely free of charge. It has no impact on your license whatsoever. Once you reuse the query data within your rules, each time you invoke this is like one API call, right? And this is versus here we have like 5 API calls plus this script node here that would be called. So these would be 6 API calls, and now we have like only 1 API call using this query data sensor. Okay, so that improves on your monthly volume of API calls as well. The next subject, which is data scientist enablement. We already have quite a number of features available for data scientists, like bring your own ML, etc. But how can a data scientist now use this in an easy way? Okay, what we have is we have now an official Python SDK that you can download from the official Python website. So for those people that are familiar with Python and using Python in Jupyter Notebooks, for example, you can actually go here into the documentation and see how you can install it. And it's actually quite simple. If you go to this public site, which is on pypy.org, we have published our Waylay package, and you can simply install it using the pip command into your environment, and that will install a Waylay client that you can use in your Jupyter Notebook. Here, for example, I have a Jupyter Notebook open that I'm running here on my PC. And here, once you have installed this Python package, you can actually import it into your notebook. So here, I'm basically importing Waylay client and Waylay error as part of the Waylay package. And then you can use and instantiate that Waylay client to connect to your particular Waylay instance. Here I'm connecting to demo.waylay.io. In your case, your URL will probably be different. Once you run this, you will be asked one time to enter your API key and secret. For those people that don't know anymore what that means, well, it basically means that if you go to your user, if you're logged into the admin console and you go to your user profile, here you can find API key and secret. So these are mine, of course, and this is what I'm currently using when running this or setting up this Waylay client. Okay, so I've already done that, and the first thing that you can do, for example, is to fetch the list of available bring your own ML algorithms that are already running on that environment. So if I run this, for example, there we go. I have here 5 algorithms already running: a TensorFlow model, a probabilities model, isolation forest model, and so forth. Okay, so that's one capability of the client, is to interact with the bring your own ML API in an easy way. What you can also do is interact with the time series data. So here, for example, I define a query specifically for my bearing resource. Hey, show me the data for this particular time range and these particular metrics. So if I run this, for example, then here this client, the Waylay client here, will interface with the time series database and execute our query. And yeah, you'll get back your data. We put that into a data frame, and then we plot that data frame here. So here you basically see the time series data of our bearing here, and the horizontal and vertical vibration models. Okay. What else can you do? Well, you can, for example, create an anomaly detection algorithm, which is basically what I'm doing here. So I'm using the sklearn isolation forest algorithm to create and train an anomaly detection algorithm on my data set. So the data that I just queried, here I'm basically going to use this data to train my isolation forest anomaly detection algorithm. And then, of course, you can also test that algorithm against, again, a separate data set in your time series data. So here again, we define a new query, and the data is looking like this here, for example. All right, that we're going to use to validate our algorithm. And here I'm using the predict function on my algorithm to check, hey, how many of these samples are actually anomalies. And you can see a number of -1s here already, which indicates that these are falling outside the expected cluster of data of the isolation forest algorithm and are actually considered as anomalies. Okay. Once you're happy with your algorithm, you can then again use the Waylay SDK to upload your algorithm with a few simple commands. So here I use the Waylay client to upload my trained algorithm. I have to indicate what type of algorithm it is. In this case, it's an sklearn framework. And I have to provide some description in here and also a name for the algorithm, which is, for example, isolation forest. And then I upload it, okay? You can then also call that algorithm, right? And basically do the same as what I did before, but ask Waylay to kind of execute the algorithm in the Waylay environment against a data set that that have been defined here before. So here I'm doing a run against the algorithm that is uploaded onto the Waylay platform, and I'm actually getting back the same anomalies as I was getting back here during the design of my algorithm. So that allows you also to test whether the upload of the algorithm is actually is working, and whether the algorithm can actually be called either through this Python SDK, but also through by the rule engine itself. So effectively, that's what we've done here in this template before. So where we were analyzing the bearing data and the horizontal and vertical vibration data. And here I've programmed my bring your own ML predict node here to call a particular model called isolation forest, which is what I used and trained here using my Python SDK. Okay, so feel free to use this. I would say you can make very complex algorithms or very simple algorithms using notebooks. You don't have to use Jupyter. You can use any data science tool as long as it's Python related. So here I talked about the Python SDK. It's available to everybody, and feel free to experiment with it, I would say. Okay. All right. Let's get back to the agenda and talk about a new product module called the Technician Provisioning Portal. What is this about? Well, we often encounter customers that have a team of technicians, people that are in the field that need to provision devices, and basically want to make sure that as soon as the devices are provisioned, that the necessary metadata is entered within the Waylay environment, such that the rules can be started on those new devices. Okay, so what we did is we created a portal that only technicians can access, and that you can without any coding whatsoever, that you can program to show the necessary inputs that a technician has to provide in order for the devices to be properly provisioned within the Waylay platform. Okay, it builds on a concept called resource constraints, which we released a couple of months ago already. But here I'm going to show a very concrete use case on how to use these resource constraints. Okay, there's also quite a bit of documentation here on our website that talks about how this actually works in detail and how you can access this. Note that this is a new licensed feature. So by default, it's not enabled for everybody. But if you're interested in using this, please let us know, preferably via Zendesk, whether you want to use this for your particular technicians. Okay. So let me show you a very concrete use case. Okay, so let me open the provisioning portal. So in this case, I'm going to a particular URL here. It's called provisioning.waylay.io. I'm going to connect it to my demo environment. So what you see here is the view that a technician will get. Okay. So it's, as you can see, it's a quite simple website. that the technician can use on his PC or on his mobile device. And the first thing that he will have to do is select a particular customer. In our terminology, it's called organization. But for example, let's take this customer and also the device type that he would like to provision. Okay, so imagine that we are dealing with a technician that is installing a fancy electrical installation at a customer's house. So what we are going to provision here is a resource of the type house. Okay, so what is happening now is that this resource type called house has a number of resource constraints. And based on these resource constraints, the rest of the portal here is automatically shown here as the required inputs that a technician has to give in order for this resource to be provisioned within the Waylay platform. Okay, what does that all mean? Well, if we go to our Waylay platform and we take a look at the resource types and go to house here, for example, you will see that the resource type called house has a particular constraint. Okay, so if the technician wants to provision a particular house that belongs to a particular end user, for example, he will be required to fill in all of this information before this resource type can be provisioned on the Waylay platform. So it's kind of a way for us to force the person that is provisioning this information to enter the right information before the rules can be started. Okay, so let's have a look at what these house constraints actually are about. So for that, you have to go to resource constraints, and let's have a look at house constraint here. So this house constraint is something that you can completely program here. For example, here we require that the technician has to enter a telephone number of the house owner. So if you expand this here, for example, you will see that this is the name. This is a telephone number, which is a required property, and it will be a string. For example, the email will be a required property again that the user has to enter. And typically this is used by the rule to, let's say there's something wrong with the electrical installation in this house, that this email address will be used to notify the user if there's anything is wrong, for example, right? So obviously the rule has a need for this information, and this is something that a technician really has to enter before the rules can be started. Okay, it can also become a little bit more complicated in the sense that we can also have additional attributes here. For example, priority 1, which is a resource reference, meaning that the technician is required to enter the priority 1 device, which is a complex electrical installation with a photovoltaic installation, including a house battery and so forth. And if these priorities mean that if a certain appliance is assigned to priority 1, this appliance will be the last one that will be shut down when there's a lack of energy in the house. Okay, so here we're effectively defining a link, a resource reference link between the house itself that we are provisioning and an additional appliance here through this resource reference. Okay, so how does it work in the provisioning portal? Well, here again, in the beginning, the provisioner selects the customer. He selects that he wants to provision a particular house that belongs to a particular end user. And then here is the ID that he has to enter for the house. Let's say house, I think I already have like a house here that is provisioned, or house 1, 2, 3, 4, for example. So this one can be created. And then here for the priority, he can actually create now or link this priority 1 to an existing appliance. So let's assume that the appliance does not exist. The provisioner can create one as well and say this is appliance 3, for example, right? So here he can create it. Okay. Appliance 3 can again have constraints that will then again be populated here with required inputs that a provisioner has to enter, right? So if the provisioner enters all of this information, then he can click submit, and then the necessary resources are created, parent-child relationships are made using these resource references between the house and any appliances, right? I'm going to skip here a little bit the full process, but I already did it before. So if I go to resources here and I filter on house here, this is, for example, a demo house. And here you can see an actual house that was provisioned using that provisioner portal. And you can see here in the metadata that all the necessary information has been entered. A telephone number has been entered, an ID has been given, the email has been given for the user, the city has been entered, and links have been made to additional dependent resources, I would say, the battery appliance, the appliances have been assigned to priority 1, 2, 3, and so forth. And so you can actually follow these references because they're actually pointing to additional resources here within the Waylay platform. So here you can see the actual battery installation of this house. Yet another resource within Waylay. Okay. So I hope that was a little bit clear. So as you can see, in order to build this page, in order to customize this page for your case, there's actually no coding whatsoever that has to be done. And the only thing that you have to define is resource types and resource constraints or type constraints, be specific. Okay, and based on that, this page will automatically be populated depending on what is really required as input if you want to provision a particular device. And then all of these fields will be automatically shown here on the page. Note that there's also a new role within the Waylay environment called provisioner. So if you want to provision technicians, for example, you can do it here via user management, and you can assign them a new role called provisioner. That means that the user will only be able to log in to the provisioning portal, but will not have access to this administrative console, for example. He will only be allowed to provision devices, and that's it. Obviously, these roles can be customized. Okay, so as I've said, this is a separate module that we recently introduced, and it has a separate price. So it's not included standard within the product. If you are interested in this, please let us know. The pricing is actually quite simple. It's just a flat fee per month per technician account. So that's something we can definitely share with you if you're interested in this feature. Okay, let's have a quick look at some of the new Waylay dashboard features. We've introduced quite a number of features. The full list is actually listed on our release notes. As you know, these release notes are on our docs page. So if you go to the docs page, you go to release notes, you'll find a more elaborate list of release notes here on this page. But I'm just going to highlight a few important new features that we have. And one of them is what we call the SCADA widget. Let me show that to you. Let me jump to a particular scenario that I've set up, which is about a wheel loader. So what we're monitoring here is the health of a particular heavy duty machine. It's called a wheel loader. Let me take this one here, for example. So this is, for example, a dashboard that we've built as an example related to monitoring a wheel loader. And what you see here in the middle is an SVG image, a vector representation of the wheel loader, where you see an overlay, which is a kind of a red rectangle for the left-hand side or the right-hand side that is currently flashing. Okay. So with the SCADA widget, what you can now do is you can actually link the behavior of certain parts in your SVG image to, for example, metric data. So if I go here, for example, and click edit, what we are doing here is this image that you see here of the wheel loader, and then particularly the red rectangles are actually mapped here, and this is what you can actually see in the widget, to a particular state variable called major impact detected, and that's a metric that is in the time series database. Okay, so how do you actually define the behavior of this this wheel loader? Well, we use an external tool called Archer for that. Let me show you in particular how you can actually define and create that. Well, here, this is the application that we use to actually define the behavior of the widget when the metric is changing. Okay, so what you see here is a particular metric called major impact detected that can have like values between 0 and 1, for example. So if I move this line here, you can actually see that depending on the value that the metric has, that you basically change the color of the rectangles. Okay, so in fact, what you can do with this designer is define multiple objects here within your SVG and define the behavior of these objects in your SVG, and then using this widget, link the behavior of these objects with a particular metric within your time series database, which basically means that if in your time series database you have like a 1 or a 0 indicating a heavy impact of your machine, well, this widget will automatically adjust itself to that state of that variable or that metric in the time series database. Okay, so using this Archer tool here, what you see here, you can design your SVG and the context associated with that, and then you can upload that SVG and that package to the Waylay environment, and you can do that in this way. So let me go back here, demo. So here, if you go to your organization, you will see that there's this new field here, SCADA, where you can upload one or more SCADA widgets. Basically, it's based on SVG, so you can use the Archer tool to create your SVG, and it also comes with a certain settings JSON, which is basically defining the different objects within your SVG and how they can be mapped to a particular metric in the Waylay time series database. Okay, we also have the alarm timeline widget, which is also useful to mention. For those that are familiar with the dashboard, this is a time series widget where you can enable alarm timelines. It's optional, you can enable or disable it. But what will happen if you enable it is that below the time series graph, you will get this view here, which indicates where a certain alarm has been triggered and whether that alarm is still active or not. So what you can see here, for example, is that there are a few warning alarms being generated, and each time a new alarm is created, a dot is put here on the time series or the time x-axis here in your graph, such that you can easily compare metric values that you show in your time series widget with the timestamp when certain alarms are getting hit. Okay, so in practice, for example, this is how it looks like in a real environment. So here I have a time series widget, and here I have shot in a particular alarm, a major alarm. I think it was yesterday that I shot it in, and basically you see here the timeline when this alarm was generated, and you can correlate it easily with the time series data. Okay, so the way to to edit this or to enable this is here, alarm timelines, where you can actually select which resource you want to use. And then Waylay will know, okay, what kind of alarms are associated with that resource, and they will be points on this graph here below your time series data. Okay. Right, so that's pretty easy to use. Right, so we also have configurable action frequencies. That's something that customers were asking for a long time. So whenever you create a task using the Waylay dashboard, which is effectively creating a rule on the Waylay platform for email messages or Twilio SMSs now, you can configure a particular frequency on when SMSs need to be sent. So you can either choose always, which basically means that whenever the task or the condition will be triggered, an SMS will be sent, or you can define a frequency. For example, 3,600 seconds basically means that it will be the SMS will only be sent at maximum once per hour. Okay, so this is part now of the create task widget, and you can define that here within the dashboard. Okay. All right, I just arrived at the end of the presentation. Thanks for joining.